This will make it very, very easy for us then to find our current, because we know that in a series circuit, our current is the same everywhere. So now if I want to find current, I can make a note. So let's make rule number 2. Rule number 2 is the current is the same everywhere, which means whatever I total is, that will be equal to the current at position 1 or through resistor 1, which will be equal to the current through resistor 2, which will be equal to the current through resistor 3, and so on. So no matter where we are in this circuit, we're going to get the exact same amount of current. Well, let's just, we might as well solve for it. So if I want to figure out I total, I could use V total equals I total times R E Q. All I did was use Ohm's law, but with all of the variables that would represent the total of each of these values. So we have a 120 volt voltage source is equal to an unknown current times, we said that the equivalent resistance or the total resistance was 12 ohms. So I'm going to divide out 12 ohms, and I can see that my total current and the current everywhere in the circuit is going to be 10 amperes, which is going to be equal to I1, which is equal to I2, and so on. It will be the same everywhere. Okay. The last thing, which is a point that I was trying to make, so the last rule for series circuits is that voltage is also additive, similarly to resistance. Remember the analogy that I made before. So I'm going to redraw this circuit. We have 120 volts. We have resistor 1, resistor 2, resistor 3, resistor 4, and resistor 5. Now, let's just remember what these are. 5, 2, 1, 2, 2. 5 ohms, 2 ohms, 1 ohm, 2 ohms, 2 ohms. So we have 120 volts. V total equals 120 volts. So what's going to happen here is, given that our current is the same everywhere, so current through this whole circuit, we said is 10 amperes. That is our current. Well, if you know the current, and if you know resistor 1 is 5 ohms, can you use, we could say I1 is 10 amperes. Can you use this information to find the voltage drop across the first resistor? Remember, we climbed up 120 volts, or analogous to 120 steps. Each of these resistors is going to bring us a certain number of steps, or a certain number of volts, down closer to 0. Because remember, this end is 120 volts, this end is 0 volts, and each of these resistors is going to step us down in voltage, down a little bit more in voltage, down a little bit more in voltage, and so on and so forth, until we're back down to 0 volts. So I'm actually going to give you a tool for this. Let's first just define what the rule is. So V total equals V1 plus V2 these rules are all in the reference table, but they're only expressed as the formulas that I've given you here. So obviously they don't write it out in words, but you'll see the three things that I've boxed in yellow. And then this. Okay, so now I want to actually solve this entire circuit. And I'm going to show you a tool that I will encourage you to use. So here is a gift from Ms. Spinelli. Here